Let us take a look at this question. Cos of 3 pi by 2 plus x, cos of 2 pi plus x times a huge bracket. What does that bracket have? Cot of 3 pi by 2 minus x, cot of 2 pi plus x, and that is equal to 1. This is what is being asked. So for proving this, once again we need something called concepts of allied angles. What are concepts of allied angles that will require over here? What is cos of 3 pi by 2 plus x equal to? That is something which we require. Cos of 2 pi plus x is pretty simple. Cot 3 pi by 2 minus x and cot 2 pi plus x, which is once again very simple. So let's begin with the LHS. Cos 3 pi by 2 plus x is what we require, times cos of 2 pi plus x, and in the bracket what you have is cot 3 pi by 2 minus x plus, what is this? This is cot of 2 pi plus x. That's what you have, right? So let's take a look at this. Cos 3 pi by 2 plus x, we are actually looking at the fourth quadrant over here. In the fourth quadrant, cos is supposed to be positive, but since this is 3 pi by 2, that is odd multiple of pi by 2, cos will convert in terms of sine. So this is actually equal to sine x. This is equal to plus sine x, right? Using concepts of allied angles. What is this equal to? Cos of 2 pi plus x is same as x. What about this over here? Cot of 3 pi by 2 minus x. Let's recall cot of 3 pi by 2 minus x. 3 pi by 2 minus x is actually this quadrant, right? 3 pi by 2 is that line and 3 pi by 2 minus x is that quadrant. This is the third quadrant. In the third quadrant, cot is positive, but 3 pi by 2 will convert, because of 3 pi by 2, cot will convert in terms of tan. So this is plus tan x. What about 2 pi plus x? 2 pi plus x is pretty simple. This is the angle that I am looking at. This is the location that I am looking at. And in the first quadrant, cot of 2 pi plus x would be actually equal to simply cot pi only. This is cot of x, right? This is what you have. So tan x plus cot x in the bracket and sin x times cos x over here. This is what we have. This is sin x times cos x times, what is this? Tan x and cot x can further be written in terms of sin and cos. And what you get is this is sin x over cos x plus cos x over sin x, right? This is what we have. And can we take the LCM to simplify this further? Yes, let's do it. This is sin x, cos x, which is okay. What about this? This becomes sin square x plus cos square x in the numerator. And what you get in the denominator is sin x times cos x. Pretty interesting. Why? Because we already have a sin x times cos x in the numerator, we get something similar thing in the denominator. These things will get cancelled, and what we get is sin square x plus cos square x. Sin square x plus cos square x is nothing but 1, and yes, the same value is there in the RHS. So this is equal to RHS. Is that all? Yeah, that is all. This is the complete proof of this question. Is that all? Yes, that is all. That's the complete proof. What we have used is simple concepts of allied angles. Simple concepts of allied angles. On the basis of that, it was very easy to solve this question.